Okay, hello everyone. Good evening and welcome to the Marshall W. Allworth Planetarium. My name is Jessica. I am the Planetarium Director and will be your tour guide to the dark skies here this evening. You've also met Spencer and Braden, two of our students who work here. So for our show tonight, we are very happy to be a part of Celebrate the Night Sky Week. And so at our show tonight, we will be exploring these dark skies, talking a little bit about light pollution and the unique resources that we have here in Minnesota. And then at the end, we'll show you some of the cool things that you can find in the dark skies. Now, if you have any questions throughout the show, feel free to just ask. I can't always see hands from at the back, so you're welcome to ask your question out loud. If you're not comfortable doing that in front of the audience, then you can always come talk to me after the show as well. And if during the show you need to leave, you're welcome to do so. You'll just exit through the same door you came in. Just, of course, be careful because it does get dark in here. And with that, I'm going to head to the back and we'll get started. Okay. So we are going to get started here. First with a short video that was produced by the International Dark Sky Association called Losing the Dark, which is all about light pollution.
We live on the surface of a planet, spinning on its axis once every 24 hours. Its rhythms of day and night are embedded in the biological makeup of all life. During the day, we bathe in the glow of the sun. As night approaches, darkness takes over. It's a time to rest, to rejuvenate, to marvel at the beauty of the night. Until just over a century ago, our night skies were very dark. Now, even the wilderness is invaded by light. Our cities glow at night. Buildings are lit up. Unshielded lights blind us as we travel along our streets and roads. All these artificial lights overpower the darkness. The waste of energy is obvious, even from space. Much of that yellow glare the astronauts see comes from streetlights. They produce most of the light pollution on the planet. The glare is scattered by the atmosphere, creating sky glows over the landscape. We are losing the dark of night at the speed of light. Light pollution threatens the health of every living thing on Earth. Lights at night disrupt plant growth. Unshielded lights contribute to the deaths of countless land and sea animals each year. Migrating birds crash into illuminated buildings. Newly hatched sea turtles mistake the glow of electric lights for the shimmer of the ocean's surface. Bright lights at night also directly affect humans. Drivers and pedestrians temporarily blinded by poorly designed lights have suffered tragic accidents. Light pollution poses a silent threat to our health. Exposure to light at night disrupts the circadian rhythms that regulate our sleep cycles. People working at night under bright lights or living in light polluted cities face a higher risk of developing diseases such as breast and prostate cancer. Here is a night sky with typical light pollution. On a good night, only the brighter stars and planets pierce the glow. This is what the night sky might look like if we could remove the light pollution. That faint band of light stretching across the sky is the Milky Way, our home galaxy. Because of light pollution, many people have never seen it. Astronomers know all too well the problems caused by lighting up the night. They need clear, dark skies to study the many fascinating objects in the universe. Light pollution simply washes out their view of the cosmos. Lighting up the night sky wastes money and fossil fuels. To keep a 100-watt light bulb turned on every night for a year takes the equivalent energy output from burning half a ton of coal. Multiplied by the billions of lights blazing up from Earth, the cost of energy we use to light up the night is colossal. While lighting is needed, there are some simple things we can do to ensure that it's neighborhood friendly, energy efficient, and helps preserve dark skies. We can replace light fixtures that send light up to the sky with ones that direct light down, exactly where we want it. They're called fully shielded fixtures. We can also illuminate only the places that need it. And of course, we can just turn off unnecessary lights. These are smart ways to use lighting. They offer simple solutions to problems caused by light pollution. We have a choice between wasting resources by sending light to the sky or learning to use light more responsibly. Light pollution is a problem each of us can help solve. Together, we can bring back the dark of night to planet Earth.
Okay. So, let's talk about this just a little bit more. Let this finish running. There we go. So if we take a look at the US, what we're seeing here is a map of light pollution. What's happened is people have measured how bright the night sky is at different locations and made a map of it. So the kind of reds and whites are the brightest, so the most light pollution. So obviously we can see, a lot of light concentrated around cities and big cities and things like that, just like we would expect. One way that we use to talk about light pollution, we use a scale called the Bortle scale. And this is just an easy way to talk about, how bad or good the light pollution is at a location. So a level 9 is going to be your worst. That's going to be like in the middle of a big city. You're going to see, maybe a few of the brightest stars, but that's about it. And then a level 1 is your pristine dark skies with no artificial light pollution. And to give that on a more example scale, here you can see what the sky looks like at these different Bortle levels. And going back to this light pollution map looking at Minnesota. Obviously, we have a lot of light pollution around the Twin Cities, but if you look at northern Minnesota, we actually have a stretch of land in northern Minnesota that is a level 1 dark sky, a pristine dark sky with no artificial light pollution. This is the Boundary Waters. It has been designated as a international dark sky sanctuary, and it is in fact the largest in the world, and it's essentially in our backyard. Um, Having dark skies like this, especially so close, is an incredibly rare thing. If we're looking at the United States east of the Mississippi, this is one of two places that you can experience that. The other being the very tip of Maine. So we are very fortunate to be living in an area that we have access to such true dark skies, and can see the night sky as it was meant to be seen. So with that, let's turn ourselves to the night sky and take a look at some of these things that we can see in our dark skies. So we're starting off here looking in the north. I'll go ahead and put the date and time up. So we're looking here a little bit later into the night after the sun has fully set. We're getting no excess light from the sun. First couple of things that I want to point out are a couple of shapes in the night sky that are probably familiar to you. We, of course, have the Big Dipper over here in the northwest. Now, the Big Dipper itself is actually not a constellation. It's an asterism. So that means it's a smaller part of a larger constellation. So the Big Dipper is actually the 7 brightest stars in the Greek constellation of Ursa Major, or the Big Bear. Now, there is one star in particular in the Big Bear, or the Big Dipper, that I want to point out. And it's this star right here. And kind of like the bend in the handle, or the bend in the tail of the bear. Now, at first glance, it looks like just a single star. But if you have really good vision, you may actually notice that there are 2 stars there. These are Miser and Alcor. And this is what we call a visual binary, or a visual double star. There's 2 stars that look like they're close together just from our perspective, but they're not actually close together in space. And this double star here of Miser and Alcor has actually been used for centuries, actually thousands of years, millennia, by ancient cultures in a lot of different ways. A lot of times it was used, honestly, like a vision test. Because if you had good vision, you could distinguish that there were 2 stars there. Some cultures looked at it the opposite way, and they actually used it as a test of age, because as you get older, your eyesight gets worse. So yeah, next time you're out in some dark skies, take a look at the bend of the handle of the Big Dipper. See if you can distinguish those 2 stars there, or if you are like me with terrible vision and will only see a little fuzzy dot in the night sky. And while you're taking a look over at the Big Dipper, if you have with you a pair of binoculars or a small telescope, there are a couple of galaxies on either side of the handle of the Big Dipper, or the tail of the Big Bear. Now, the one above is what we call the Pinwheel Galaxy. And it's going to look something like this. It is a beautiful spiral disk galaxy. And the one below the handle is the Whirlpool Galaxy, which is another spiral galaxy, but I like this one because it has a little friend with it. So you get two for the price of one there, looking at the whirlpool. Yeah, so this is the view that you would have with, I believe I did a 6-inch telescope. Yeah, the colors may not be as vibrant because cameras just pick up better on color than your eye does. But yeah, this should be close to what you would see in a 6-inch telescope. All right. If you don't have a pair of binoculars or a telescope, don't worry, because there is a galaxy that you can see in the night sky with just your eye. So to find it, we're first going to need to find the Greek constellation of Cassiopeia. Now, she is pretty easy to find. She is this big W here in the night sky. Sometimes of year, it looks more like an M than a W, just depending on, how you're oriented, but that's what you're going to be looking for. And it's a very bright constellation. It's one that you should be able to find pretty easily. But what we're going to do is we're going to take trying to find my laser pointer. There it is. We're going to take the rightmost V in the W, and we're going to treat this like an arrow. And so that arrow is going to point you over here to this little fuzzy blob there. Let me get it circled. There we go. That little fuzzy blob is the Andromeda Galaxy, named for the fact that it is found in the constellation of Andromeda. There she is. But yeah, you don't have to have a telescope to see this one. You just need dark enough skies and to go out at the right time. This is very prominently seen in the fall, so we are really hitting prime time for seeing the Andromeda Galaxy. So that's another thing to check out next time you go out in the next couple months. Find yourself in some dark skies. First find Cassiopeia, and then use her to point you over to the Andromeda Galaxy. And you will be seeing with just your eye a galaxy that is 2.5 million light years away. So a light year is distance. It's the distance that light travels in 1 year. And it's equivalent to about 6 trillion miles. So it would be 2.5 million times 6 trillion to tell you how many miles away it is. Yeah, it's crazy. And you can see it with just your eye. Now, if you do have a pair of binoculars or a telescope, you'll be able to see a little bit more detail. It is another spiral disk galaxy, and this galaxy is actually larger than our own, than the Milky Way. It has about twice as many stars as we do. Speaking of, our Milky Way is another great thing to try and find in the night sky when you have dark enough skies, and you can hopefully make it out here as this fuzzy band arching across the sky. I'm going to turn us around to the south. So the sky is going to move so that I can bring the south to the front so that you're not having to look behind you or anything. So if you're worried about things spinning and feeling, a little motion sickness or anything, just close your eyes right now and I'll tell you when to open them back up again. But we're going to spin around to the south right now. Okay, we are now looking south. We have stopped moving. And you will hopefully be able to see here that the Milky Way looks a little bit brighter, a little bit more prominent looking south. And that's because right now, and more so deep summer, but right now, looking south, we are actually looking towards the center of our galaxy, where there's just a lot more stuff. And so it looks a lot bigger and brighter and more vibrant. The summertime Milky Way is something that I think everyone should see. And it's really sad. I think the statistic is now at like 85% of people have never before seen the Milky Way in the night sky because of light pollution. So yeah, if you haven't seen it, absolutely go see it. And again, this area, you don't have to travel far to get into dark enough skies to see the Milky Way. Now, you may notice that in it there are some darker patches. And those are actually where we have thicker clouds of gas and dust that are blocking the light from the stars behind them. And again, there's just a lot more of these as we look toward the center of the galaxy. So we're seeing a lot more of those dark areas. All right. So I have a few more things that I want to show you. For this next one, we are going to look over to the west. So again, I'm going to move the sky just slightly. Okay. I'm also going to remove these galaxy names just to give us a little bit clearer sky here. And we're going to do a little bit of star hopping to go and find one of my favorite things to look at in the night sky. So we're going to start off by star hopping using the handle of the Big Dipper. Now you'll notice that it's curved or it's arced. So what we're going to do is we're going to follow the arc of the handle as it points us down to this bright star here named Arcturus. So again, you arc to Arcturus. Now Arcturus is part of the Greek constellation of Bootes. It looks kind of like a kite or an ice cream cone or like a giant turkey leg. It's actually a man. Really takes some imagination there. But right next to him sits this C shape. Or I guess it's more of a U this time of year, which is Corona Borealis, the northern crown. And if we go just a little bit further past our crown, we will find our great hero, Hercules. Now, we went through all of this trouble to find Hercules because right here in his side sits my favorite object to look at through, again, either a pair of binoculars or even a small telescope. This is what's known as the Great Globular Cluster of Hercules. Now, a globular cluster is a group of stars. Globular clusters typically have thousands to hundreds of thousands of stars that are packed really close together and make this kind of spherical blob of stars. Now, this one I particularly love because it's one of the brighter ones that we can see in our night sky. And it's one of the closer ones so that you can actually see individual stars. All of the light doesn't get blurred together. You can see some individual stars there. But as light passes through our atmosphere, it kind of gets bounced around by like turbulence and things in our atmosphere, which is why if you've ever noticed and seen stars twinkle, that's what's happening. That's what causes the twinkle. But when you have that happening as you're looking at this little cluster of stars, it makes it look like you have these just like glittering jewels in the night sky. It is absolutely beautiful. I've also had students describe it as like someone blew a puff of glitter into the eyepiece of the telescope. But yes, highly encourage trying to find this one. Again, if you follow our star hopping and make your way over to Hercules, it's going to be right in between those two stars in the side of Hercules there. you say a little bit louder? Oh, yeah. So, especially in the center of globular clusters, those stars can be really close together, like closer than even a light year. Um, for reference, the closest star to us, or to the sun, obviously the sun is the closest star to the Earth, but the closest star to our solar system is over 4 light years away. So they are really close together there. Yeah. Which it actually reminds me, there is a really great short story, and I always forget the name of it when I'm put on the spot like this. I should really just like write it down on my hand or something. But there's this really great short story that was written about a planet that lived in a multi-star system in a globular cluster, and because of that, it was daytime all the time, except for about once every like couple thousand years. And so the story was about basically what happens to civilization when everything they think they know completely changes, because they didn't know about other stars, because they always had daytime, they always had their suns up. So it's a really great story. I highly recommend, and I will see if I can find it after the show. That way, in case you're interested, I can let you know what story that is. But it's great. Okay, so I think we have time for one last thing. So we are now going to head ourselves first back to the south, because I believe we should have a couple planets. Yeah. There's Saturn, visible up over in the southeast. So Saturn this is actually a really good month to look for Saturn, because we are reaching our closest approach. So it's going to be the brightest that it will get. And right now, Saturn is really not near any bright stars. So if you're looking, southeast, and you see just a bright, what looks like a star, you're probably actually looking at Saturn there. And of course, with a telescope or binoculars or something, you might even be able to make out the rings of Saturn, and maybe even see a couple of the big moons around Saturn. Now, one quick note: there has been a news article. It's not just an article. Something making its way around the news about how Saturn is losing its rings next year. Just wanted to spell that real quick. Saturn is not losing its rings. What's happening is, because of the angle that Saturn's at versus the angle that we're at, sometimes we see the rings edge on. And because they're so thin, they become nearly impossible to see. So next year, Saturn's rings are going to be edge on. So for a little while, they won't be visible to us for just a little while, but they're not just disappearing. It's just our viewing angle is making them not visible for a little while next year. And if we go a little bit later into the night, over in the east, we're getting Jupiter rising, and then Mars. Let me pause time real quick and move us to the east so we can see those a little bit better. There we go. So we got Mars and Jupiter there. Now, right now, they're rising, around midnight, being really easily seen after midnight. But over the next few months, they are going to be rising earlier and earlier. And so in a few months, they will be visible right after sunset. So either You're going to have to stay up late to see them, or just be patient and they'll be up after sunset fairly soon. But if you are taking a look at the planets, there is one more thing that you can be on the lookout for, and that is, where's it at? Here we go. This group of stars right here. Now, a lot of people mistake this for the Little Dipper because it's kind of dipperish in shape and little. But this is actually the Pleiades, or the Seven Sisters, which is another star cluster. Instead of being a globular cluster like the Hercules star cluster was, this is what we refer to as an open cluster. So fewer stars, but it's still a beautiful thing. And you can see this easily with just your eyes. Even in some light pollution, like I have seen the Pleiades easily from downtown Duluth. So if you're in an area where maybe you can't get out of the light pollution as well, the Pleiades is one thing that you should definitely be on the lookout for, because that's something that you should be able to see. All right, well, I think we're at time. So what I'm going to do now is just fast forward through the rest of the night. Right before the sun comes up, we should catch a glimpse of 2 more planets. Or I have my timings wrong. Nope, there we go. Right before sunrise, Mercury is showing up. I think I was wrong on Venus. That one's going to be a little bit, not quite yet, but yeah. That brings us back to the day and to the end of our show. So I'm going to slowly bring the lights up. And before you leave, I just want to make note, in front of the TV at the main entrance, you can find some star charts to help you find a lot of these things that we talked about here. You can also find some information on light pollution and how to, minimize it if it's something you're interested in trying to, have better lighting at your own house. And yeah, I will be back here if you have any questions. Thank you all so much for coming out. Have a safe trip home and a wonderful rest of your week.